The moons of our solar system's gas giants continue to surprise us with their variety and complexity. So much so that the space agencies of the world are shifting their major scientific focus towards these fascinating little worlds. But among them is one that is fast becoming one of the most important worlds to study in the solar system, Europa. Europa was discovered in January 1610 by the father of astronomy, Galileo Galilei, through a telescope. He saw that Jupiter had 4 companions around it, and eventually they were named after 4 lovers of the Greek god Zeus, because Zeus is Jupiter's Greek counterpart. These 4 moons, Io, Europa, Ganymede, and Callisto, have since become known as the Galilean moons after Galileo Galilei himself. Europa is the second moon out from Jupiter. It orbits at around about 670,000 kilometers from Jupiter, and this orbit takes it around about 3.5 days to complete one circuit around the giant planet. And this is actually the same as its rotation period, and this means it is tidally locked towards Jupiter, as is the case with every large moon in the solar system. Europa is about 3,122 kilometers in diameter, which is slightly smaller than our moon, and it is the smallest of the 4 Galilean moons. Europa's mass is about 48,000 billion kilograms, but of course that is incomprehensible to imagine, so that makes it about 0.8% the mass of Earth. But quite surprisingly, it has a high density. In fact, it's the 3rd densest moon in the solar system after Io and our own moon. And we'll get on to why this is interesting later. So for hundreds of years since Galileo discovered Europa, we had no idea what it looked like until the 1970s when the Pioneer probes flew past. But even then they didn't take very good photographs because their machinery wasn't as advanced. But in 1979 the Voyager probes took the first close-up pictures of Europa, and it revealed a fascinating world. The surface was made almost entirely of water ice, but what was also interesting is that it was nearly completely devoid of any craters. There's only a few craters on the surface, but instead of lots of craters, they found that Europa was covered in these giant fissures and cracks all over its surface, and it found all this jumbled up terrain that almost looked like there were icebergs floating on flat pieces of ice that looked like they could have been liquid at one point. And not only that, but the fractures and the lines all over Europa's surface tend to be quite colourful. There's a lot of colour over the surface of Europa that is not too obvious in the animations in Space Engine that I'm showing here, but this is the natural way that Europa looks. If you have a picture with enhanced colour, you can really see all this coming out quite significantly, and the lines appear to be reddish brown. So it was clear that Europa was a world that was vastly different to anything we had seen before. Immediately the question is, why then? Why is Europa so unique in comparison to everywhere else in the solar system? Why is the terrain so jumbled? Why are the lines coloured? And ever more mysteries. And just like Io, which we discussed a few videos ago, the answer to all of this appears to lie with the giant planet in which Europa orbits. So, analysing these lines and fractures and the jumbled terrain on its surface, we found that this is actually all caused by gravity. The gravity of Jupiter is actually stretching the surface, but also other things are going on as well, as Europa is in what is called an orbital resonance with 2 of its other fellow moons around Jupiter, Io and Ganymede. Io goes around 4 times around Jupiter for every 2 orbits of Europa, and Europa goes around twice for every 1 orbit of Ganymede. And that imparts more gravitational kicks onto all 3 of the moons, and it makes all 3 of those moons have slightly elliptical orbits, only very slightly though. But this is enough for the gravitational forces from Jupiter to change, And it's a gravitational change that matters in systems like this. It's how Io is so volcanically active, because it's the closest of all Jupiter's moons, and the effect is strongest, and it's resulted in those fiery explosions on its surface. And this gravity change causes brief melting episodes in the surface ice as well. And then when it gets further away from Jupiter, it slightly cools, and then the ice refreezes. And since counterintuitively ice expands when it freezes, the energy comes out of the ice when it freezes, and so the canyons that we see, the lines and fractures, they get cleaved apart ever so gradually over millions and millions of years. And in fact, the colours that appear on these lines appear to be also coming from Jupiter as well. For a while, when we first saw these colours, we thought that it could be sort of bacteria, but in fact, it actually turns out that it's a mixture of salt and ice that has been damaged by radiation from Jupiter. And that is what's causing the reddish-brown colours. But this is all thanks to Jupiter and its fellow moons. Without the other moons there, if Europa were Jupiter's only moon, then we would not be seeing these cracks and fissures on the surface, because there would be no gravitational difference. You see, the moons, imparting that extra gravity, keep the orbit of Europa from ever becoming perfectly circular. This is already quite exciting and interesting, considering the active world that we know Europa already is. But there's more to it. You see, this gravitational difference does something else remarkable. Within this little moon, we think lies an extraordinary secret. As various spacecraft have flew past Europa, so Voyager, Galileo, and also Juno, we found that the magnetic field of Jupiter acting on Europa actually induces a very weak magnetic field coming out of Europa, which is not possible unless there is an electrically conducting liquid beneath its surface. Also, the arrangement of surface features on Europa is very odd. The cleaving apart of canyons that I mentioned earlier, that is driven by Jupiter's gravity, should only be happening on one side of the moon. Because, as I said earlier, Europa is tidally locked to Jupiter. It always presents the same face towards its parent planet, just like our own moon does. So why is it that we see cracks and lines all over the surface of Europa? Well, we think that the only way that's possible is if the surface has slipped around relative to the rocky core. The face of Europa has moved over millions and millions of years relative to the rocky core, and this can only happen if there's something sort of lubricating this shell of Europa. The surface of Europa is actually just an icy shell that is sitting on top of a global ocean underneath the icy surface. So already this is incredibly exciting. A liquid water ocean underneath the icy surface, and we think this ocean is incredibly deep. It could be up to 100 kilometers deep. And that would mean it has more than twice as much liquid water as all of Earth's oceans combined. The implications of this are huge, because what does life need to survive on Earth? Generally, all forms of life need water for survival, but life needs more than just liquid water to survive. It needs a source of energy. On Earth, us humans get that energy from the sun. But around Jupiter, the sunlight is 25 times weaker than it is here on Earth. And of course, sunlight cannot penetrate through kilometers of ice. This ocean is in complete darkness. But we have found that in the deepest parts of the oceans on Earth, that there are hydrothermal vent systems, heat coming out of the Earth's mantle, that provide energy for numerous organisms, and these are nurseries for life. We think they are the cradle of life on Earth, the starting place for it all, because not only was the source of energy there, but the chemical elements too. So it's a very likely candidate for the starting place of life on Earth. So how does this tie into Europa? Well, there's an energy source on Europa, but it's not from residual heat, like I just described with Earth. Europa has long lost its heat of formation. It's too small to have retained that. But remember, it's orbiting the giant planet Jupiter, and that gravitational difference injects energy into the center of Europa and warms the ice and melts it, creating this ocean. This also means that Europa very likely has some hydrothermal vent systems below its surface. So there could be cradles of life under the surface of Europa. But another question remains. Is the chemistry for life there on Europa? Because life also requires various chemical elements, sort of like your sulfur, your phosphorus, your calcium, and iron. And we don't believe that Europa naturally has these chemical elements. But what it does have is a neighbouring moon called Io. As we've discussed throughout this video and in the Io video itself, Io is a furnace of volcanic eruptions. Io is almost entirely made of rock and silicates and all these chemical elements that we believe are necessary for life. And so what Io does is it blasts them up into space with its powerful volcanic eruptions, and it actually stays in orbit around Jupiter in something known as a neutral cloud. And now this cloud is big enough that Europa orbits through this neutral cloud. And so the elements that are erupting out of Io's volcanoes end up landing on the surface of Europa. But if Europa were dead like our own moon, then these elements would be separated forever from the ocean by the thick ice layer. But because of this active geology, because of the processes that go on Europa's surface, we think that the elements that are landing on the surface of Europa get transported into the ocean by the active geology and the ice jumbling around as it gets moved and broken up by the heat being generated inside the moon by Jupiter. The hypothesis of hydrothermal vents has further support from something that might not seem very obvious at first: the density of Europa. The density of Europa, as I said before, is 3.01 grams per centimeter cubed. The reason this is interesting is because if Europa was ice all the way through, ice would make up most of the mass, and so therefore the density would be much, much lower, because ice has a lower density than even water, and so the density would be closer to 1.5 or even 1 gram per centimeter cubed. But the fact that it's 3.01 means that Europa must be, despite its surface composition of nearly pure ice, it has to be mostly silicate rock towards the center. Now that's very exciting. Reason being, this means that the ocean is very likely in contact with rock, and hydrothermal vent systems can only happen from these types of rocks. They can't come out of ice. And so everything that I've just explained is so unbelievably compelling for the existence of life that it has to be one of our number one targets for searching for life elsewhere in the solar system. And it doesn't stop there. The Hubble Space Telescope in 2013 found what looks like erupting geysers on the surface of Europa. Now, we haven't fully confirmed their existence yet, but it's exceedingly likely that they are there. The existence of erupting geysers wouldn't be particularly surprising, given the amount of heat that's being generated inside Europa. Geysers are active geological features, and so seeing them on a world that we know already is geologically active wouldn't be particularly surprising. However, we have not confirmed their existence yet. But what makes it so exciting is that when we send spacecraft to visit Europa, we might be able to directly sample the ocean beneath, which will be incredibly exciting. Now, we are not done with exploring Europa. We have 2 missions on the way to the Jupiter system to investigate this little moon. JUICE and Europa Clipper. Now, JUICE is a European Space Agency mission. Its primary focus is the moon Ganymede. It will enter orbit around Ganymede, but it is also going to be studying Callisto and Europa. It will fly by Europa twice, and those 2 flybys will gather crucial data about what lies underneath that icy shell. But the most significant Europa mission is Europa Clipper. Now, Europa Clipper is the first dedicated mission to Europa. Originally, when it was first planned, it was supposed to be an orbiter around Europa. But upon review, it was decided that it would just be many, many flybys because the radiation from Jupiter that's around Europa is quite intense. To orbit Europa, a spacecraft has to be in the vicinity of Europa for a long time. And so a spacecraft that's orbiting Europa may not survive for any more than a year. And so the decision was made to change it to a flyby mission. Now, there are 53 planned flybys of Europa from Europa Clipper, and that will give us enormous amounts of data about this little icy moon. These 2 missions, Europa Clipper and JUICE, will hopefully get us closer to answering the question of, are we alone in the universe? If there is life on Europa, it will likely only be microbes, like single-celled organisms. But regardless, it'd be incredible if we found even single-celled organisms, because that would mean that there have been at least 2 instances where life has started in a single solar system. And if that's the case, then that surely means that the universe is just teeming with life. With these 2 missions, we will be able to hopefully answer these questions, or at least get closer to answering them, by exploring the wonders of this little moon orbiting Jupiter. Thank you everyone so much for watching this video. I really do hope you did enjoy. I really did enjoy talking about Europa today. Make sure to vote on the poll in my community on what object you would like to see a video on next. For now though, I really do hope you did enjoy this video. If you did, why not like and subscribe? It's free and it would mean a lot to me. Thank you very much. Thank you very much for watching, and I will see you all in the next video. Goodbye!